Hi friends, this is your first lesson for chapter 4. It's on page 1 if you are a guided notes printer-outer. So let's review from middle school the types of triangles. If you have 3 acute angles, again an acute angle is less than 90. If all 3 of them are acute angles, that is called an acute triangle. If any one of the angles is obtuse, obviously you can't have more than 2 obtuse or more than 1 obtuse angles because the total of all angles in a triangle is 180. So if one is more than 90, you can only have one. But that's called an obtuse triangle. If you have 1 right angle and the other 2 are acute, you are called a right triangle. And lastly, if you have 3 congruent angles, the word for that is equiangular, which makes sense. Okay, that's classifying them by their angles strictly, but you can also classify them by their sides. So if all 3 sides have the same length, meaning they're all congruent, that is when you call it equilateral. Okay, if only 2 sides are congruent and this 3rd side is different, that's called isosceles. And then if all 3 sides have a different measure, that's called scalene. So again, that's classifying them strictly by the details of their sides. All right, so I'm going to jump to page 3. And talk about the triangle or angle sum theorem. The sum of the measures of the angles of a triangle is 180. So all 3 of these have to add up to 180. So unlike supplementary where 2 angles added up to 180, all 3 of them do. An exterior angle, that means outside. So this angle 1 here, an angle outside the triangle that it forms a linear pair with a 3rd angle. It's always equal to the sum of the 2 non-adjacent interior angles. It's a little trick. I'll show you the long way to do it. But it's a little trick that always works, and we'll talk about why. All right, so you use the angle sum theorem to figure out the 3rd angle of a triangle. You know that one's 24, you know that one's 37, you don't know the 3rd one, but you know they total 100. So you know that if you add 24 to 37 to the one we don't know, let's call it x instead of 1, you know they're going to add up to 180. So you see what you have so far, 30, 40, 50, 61. So if it's totaling 180 and you've used 61 already, you just subtract 61 from 180. Sorry, I'm bad at mental math. 180 minus 61. So you don't have to set this up every time. Some people just get into a habit. You know that you're going to add up what you have and subtract it from 180 because you're always going to be using 180. All right, let's say they want the angle outside. This is where I'm going to show you how that theorem works. So these form a linear pair. If I were doing this, I would find this one first. So I know that 76 plus 52 plus this one I don't know inside needs to add up 180. So if I do 76 plus 52, that's 128. And then if I subtract that from 180, I get 52 degrees. But again, that's not our answer. 52 degrees is the measure inside here. Well, if you think back to linear pairs, they also add up to 180 degrees because a half circle is 180 degrees. So you know that this piece of it is going to be whatever 180 minus 52 is. Oh, but that's 128. See that right here? So that's always going to work out. If these 2 are 180, but also all 3 of these are 180, whatever these add up to is going to equal that. But again, if you don't understand, that's okay. You can still find the third angle and then use it to find the other angle. 128. Okay, what if they give you the exterior angle? So you know that out here is 104, and they want you to find this one, but they didn't tell you this one. So you're going to use the exterior angle to find this one. Again, there's multiple ways to do this problem. This just makes the most sense to me. I know that 180 minus 104 is going to equal that angle right there. Okay, but my answer is not 76. 76 is right there. Well, now I know that if that's 79 and that's 76, I can find this one. So 79, 76, plus that top angle that I'm trying to get. It's 180. If I do 79 plus 76, that's 155. And subtract 155 from 180. So that means this little angle here is 25 degrees. So again, I use my exterior angle to find this one because they form a linear pair, and then I use these two with this one in the angle sum theorem to get the missing angle. Again, if you want to use the exterior angle theorem to find that, you can. There's always more than one way to solve a problem. All right, I'm jumping to page 5 really quickly. It's on the next lesson, but I want to really connect it to this lesson for you. Because even if they give you one angle, we still just learned that these two lines mean that this is an isosceles triangle. And if you remember from middle school, these angles are going to be the same. So you can still use your angle sum theorem because you know that's going to be 68, and even though it's not labeled, you know that's 68 from those marks. So 68 plus 68 plus the angle I don't know. Again, add them up and subtract from 180. That's 136. So this top angle here, angle J is 68. And angle K is 44. So again, you're going to practice this again in the next lesson, but I wanted to include it in this video to show you the connection. All right, this one's a little bit different. This time the 106 is up here. So this is not going to be 106. It doesn't even look like it's 106. These ones you don't know, but you do know that they're going to match. Isosceles triangles, I review from middle school. If these sides are congruent, then these angles are also congruent. So this time when you set up your angle sum theorem, you're only going to have one 106. It's the x that you're going to write twice. All triangles have 3 angles, whether they're unknown or known. So you're just going to have to combine like terms with this one. But x plus x is 2x. So you are subtracting the 106. That's 74, but that's a common error. The answer is not 74. Remember, 74 is just what's left to divide up between these 2 angles. So you have to do 74 divided by 2. Why does it do that? 37. So that makes sense. If they're each 37, you can check your answers to these. Does 37 plus 37 plus 106 equal 180? And it'll check. And are those the ones that match? And that makes sense. So that is a lesson on angle sum theorem and exterior angle theorem.